Alright, welcome back everybody. In the last video we covered the cover-up method where we could easily do partial fractions with two linear factors in the quadratic denominator. Well, now we are going to be moving on to case 2. So I guess Calc 2 students, we are on our own. The BC students are off in the fields of applications of integration, which is our next unit. Or improper integrals. They're probably doing improper integrals, but that's okay. We are going to have a lot of fun continuing on our journey through partial fraction world, and we're going to cover case 2. So this is the second of our 3 cases. We're not going to be spending a lot of time on these cases. We're probably going to do one video for each. So we're going to cover the second case, and this case is kind of an extension of the first case, but it is by no means the messiest that we are going to get in partial fraction land. So let's get started. So case 2 says that the denominator has some repeated linear factors. So earlier what we were dealing with is we were dealing with non-repeated linear factors. So we had 1 over, that was so ugly, x minus a times x minus b to like x minus n. Or I don't know, whatever you want to have there. And that was easy. We could use that cover-up method. It was all nice. So now we're going to have a denominator with repeated linear factors. So we might have like x minus a squared. And we're going to say for the sake of our definition that it's repeated r times. So we can rewrite p of x over q of x, our rational function, as a sub 1 over a sub 1 x plus b sub 1, as we've seen earlier. But let's say a sub 1, it should be an a sub 1 and b sub 1. Let's say a sub 1 and b sub 1 continue to repeat r times. So we're going to need to keep adding this. So for example, say I have like, say I have something over x minus 1 squared. Well, then I'm going to need to write out a over x minus 1 plus b over x minus 1 squared. Or if I have something cubed, then c over x minus 1 cubed. So we need to keep writing it out in order for our partial fractions to work. And then we might still have some non-repeated terms, and those go out to our a sub n over a sub n x plus b sub n. Okay, now all of this, everything I just said was probably super abstract. So what I want to do is remedy this by doing an example. And this example is going to be long, just like the other ones we've done. And it throws a little bit of spice into it by having us visit an old friend from pre-calculus. So we want to take the integral of x to the fourth minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1. Okay, so as I said, we're revisiting a friend. What do we need to do now? Well, as you can see, the degree of our numerator is higher than the degree of our denominator. So we can't do a partial fraction until we have something that has a degree lower than the denominator. So we want to long divide this polynomial. And I'm going to forego all of that just because that doesn't seem worth our time to be doing something that you probably are already familiar with. So we're going to long divide the integrand, and we're going to get x plus 1 plus 4x over x cubed minus x squared minus x plus 1. Okay, so that is our new integrand. So now what we are actually going to do is we are going to throw away the other stuff so that we can more easily focus on our other friend, our 4x over x cubed minus x squared minus x plus 1. So this is going to be our friend for the rest of the example, because this we have no problem with that. If we want to integrate that, fine. X squared over 2 plus x. But this guy here still needs to go through partial fraction decomposition. So we are going to isolate the fraction and factor. So we get 4x over x cubed minus x squared minus x plus 1 is equal to x minus 1 times x minus 1 times x plus 1. Oh wait, we have repeated linear factors. So we've got x minus 1, we've got it 2 times, so it's squared. So that is going to throw a little bit of a wrench into our partial fractions, and we are going to need to do case 2. So let's write this out. So we write 4x over x minus 1 quantity squared times x plus 1 is equal to a over x minus 1 plus b over x minus 1 squared plus c over x plus 1. I don't know why I wrote those parentheses there, but that's okay. So see how we've repeated it as many times as our power is. So if it's a power of 2, we write it 2 times. If it's a power of 100, we write it 100 times. But that would be quite an evil question to be given to you on a test. So let's do this partial fraction. And actually, we're going to be able to use the shortcut that we learned in the first one because we've got these repeated terms. So let's multiply everything by the lowest common denominator. We get 4x equals a times x minus 1 x plus 1 plus b times x plus 1 plus c times x minus 1 squared. All right, so now what we're going to do is we're going to say that x could be equal to 1. So if x is equal to 1, then, well, this guy is going to go to 0, and this guy is going to go to 0. So we get to isolate b. So we get 4 times 1 is equal to a times 0 plus b times 2 plus c times 0. So b is equal to 2. There we go. We've already got the first one done. All right, so now we're going to let x equal negative 1. So that's going to cancel out these factors, and it's going to isolate c. So we get negative 1, because we got to multiply that 4. We get 4 times negative 1 is equal to a times 0 plus b times 0 plus c times 4. Then now you do a little algebra, or arithmetic really. C is equal to negative 1. All right, now this is where it gets a little complicated. It actually turns out that as long as we make sure that a, b, and c are all in the game here, by what we choose to let x equal, it's fine because we already have c and b, so we just need to find an equation where we have a, b, c, and we can solve for a. So if we let x equal to 0, then, well, 4 times 0, that goes to 0. So that's a times negative 1 because we have 0 minus 1 times 0 plus 1, so that's negative 1, plus b, so that's 0 plus 1, so 1, plus c times 0 times negative 1 squared, which is 1. So we get 0 equals a times negative 1 plus b plus c, so then a is equal to b plus c. And since we already know b and c, we can rewrite that as 2 minus 1, which is equal to 1. So a is equal to 1. Well, now we are ready to insert this all back into a lovely partial fraction decomposition, but we can't forget that term that we got from the synthetic division. So we get x to the 4th minus 2x squared plus 4x plus 1 over x cubed minus x squared minus x plus 1 is equal to x plus 1 plus 1 over x minus 1 plus 2 over x minus 1 squared minus 1 over x plus 1. All right, so now finally we are ready to perform an integration. We get the integral of x plus 1 over x minus 1 plus 2 over x minus 1 squared minus 1 over x minus 1. Okay, now you just need to perform maybe a quick u substitution for these. These are simple ln integrals, and these are simple monomial integrals. So we get as a final answer 1/2 x squared plus natural log of absolute value of x minus 1 minus 2 over x minus 1 minus the natural log of the absolute value of x plus 1 plus c. All right, that was a long one. So that's it for this video. In the next video,